morning, class. Welcome to our science seminar for today. Okay. And to see all the interest, if there's an empty seat around you someplace, and you're sitting on in, you might want to slide to the middle so people can get into a seat. Okay. There's a lot of empty seats out there, but people sitting on the steps. So you can slide over so that people can get into seats. That would be appreciated. Okay, people sitting on steps, there's seats over there, seats up there. Okay. Find some place to sit. Exciting a topic, this eclipse of your heart. Yes. Whenever you talk about, heart matters, people come out, right? Yes. And what's going to spread your heart more than the eclipse of the sun? Huh? So that's what we're going to be talking about today. And our own astronomy class is going to be presenting, their journey through the twilight zone, as it is. Yes, the day that the sun disappeared, right? And they're going to talk about the mystery and the spiritual impact upon them as it all occurred to them, right? Okay. Before we get started, though, I want to remind you that we have a seminar scheduled for next week. There are actually 2 science seminars scheduled for next week. Yes? And you might have to change the venue if people keep coming like this. Yes? We have one on the regular time on Thursday. So next week, same time, same channel. And that will be a seminar on computers and chemistry. Sang Sue from Texas A&M Commerce. She's going to be coming and talking about that. And then Friday night, John Mimati from University of Alabama and the space program there with NASA, or JPL, I guess it is, will be talking about exoplanets and the use of spectroscopy to discern exoplanets. Okay? So today it's the stars, the sun. Next week we'll talk about the planets that go about that sun. So a lot of good things coming up in science seminars over the next week or so. So keep watching latu.edu/science seminars, and all the updates will be there for you. All right, let's give a warm welcome to our astronomy teachers.
I'm Dr. Ball. Many of you know me. To my astronomy students who went with me on the eclipse trip, I'm probably Dr. Bait-and-Switch. Because I didn't tell them that we would be doing a presentation if they went with me on this eclipse trip. They found out afterwards, and so. But to my defense, I didn't know we would be doing one either. In fact, I'm here to just give you really an introduction to how all this came about, and you'll see how little planning and foresight I had in all of this, but it worked out anyway. But anyway, I guess I'm here today to talk about this eclipse. I couldn't have dreamed that all of this would have happened just a few months ago, back in the spring, before a Returno alum named Georgia Embry just called us up out of the blue and invited us to come to Kentucky to view the total solar eclipse. Because she had a big house and lots of room. And, I hadn't even done any thinking about it, to be quite frank. And I had a lot of reasons why it wouldn't be a good idea to do it. The first day of classes, August 21st. So I'd have to be missing classes. The students would have to be missing classes. And I could probably think of a number of other reasons why it would be a bad idea. But I had already been doing a lot of praying during that time period, and that's when I felt the Lord speaking to me, saying, "No, you got to go. You should go." Why? Just a solar eclipse. What's the big deal? But no, there was a strong sense that I needed to go, and I needed to take some students with me. And you'll see, I guess, some of the reasons why that turned out to be a good idea. Yeah, come on in, grab a seat somewhere. But the other thing is, I learned a little bit later that some things were happening behind the scenes that I wasn't planning at all, but were kind of being planned for me. got a call from the pastor of her church out in Hopkinsville, Foursquare Church. Pastor Delano Blazer called me up and said, I want to know the title of your sermon that you're giving Sunday morning. Oh? But, you know, that was when the Lord spoke to me once again and said, Steve, give him a title. Psalm 19, I'll be preaching from Psalm 19. Okay? For the heavens declare the glory of God. And so I just told him, that's the topic of my message. I guess I will be preaching Sunday morning. Thank you, Georgia. Of course, we would find out a little bit more about Georgia when we went to stay with her. I'll let some of them share their stories. But, a couple more things before I start introducing you more to what we actually did on the trip, because I feel it necessary to explain a few things to you. For one thing, I want to honor a very special lady who's here today, my own mother. Yeah, if you want to know some embarrassing stories about me, but I got the floor. I've got the floor right now, so I'll say a few things. And that is, for one thing, I wouldn't be here today doing what I do if not for this lady. This lady has had a huge, huge impact upon my life. And, you know, I just appreciate how this lady instilled within me the confidence that I could do whatever I set my mind to. Really, I say that, and I wish every person on earth could have a mother like I have. I really do. So, anyway, thank you.
Thank you, Steve.
Now, a little bit more about the eclipse trip. My lack of foresight and lack of planning didn't matter because it all got planned out for me. I was planning to go out in the summer to go to a short course in astronomy at the Green Bank Observatory. And so I decided to stop by and visit my good friends, the Namatis, who had just moved to Huntsville, Alabama, where Dr. Bijan Namati had taken a new position there at the University of Alabama, Huntsville, in coordination with the Marshall Space Flight Center. You'll see a little bit more on that in just a bit. And while I was there, I told him, yeah, I'm going to go visit this one lady who's going to host us to view a solar eclipse. And he said, oh, can we come? Can we come along? Sure, come along. And so they all began coordinating this whole trip for me. So I didn't have to do any planning after that. It was all planned for me by the Namatis and by Georgia Emory, who were all type A, super organized types, and that was good because I'm not. And so they told me, if you had tried to book some motels in the area, forget it. They were all booked up months ago by people who were going to be in the path of totality and had already reserved these motel rooms. So your lack of foresight and planning, well, it didn't matter, did it? Because this was all kind of fell into our lap. And so, so they all began coordinating this whole trip for us, and what we would eat, what we would do, and where we would worship, and giving the message on Sunday morning, all those kinds of things. I said, fine, let's just do it. And I felt that way because the Lord had already been kind of working on me, and I knew this was something that we should do. And it kind of evolved into more than just an eclipse trip. It was more like what I would call a mission trip in the end, because of all the things that God was doing on this trip. And I decided to tell the students, we're going to go on this trip, and you're going to get up in the morning, and somebody's going to do a devotion every day, and share with the group what God is showing and teaching you. And so we did that. And so And God just seemed to do a lot of neat things during this whole trip. And I praise God for all of this because I certainly didn't plan this out. What's on the next slide? Okay, let's go ahead and take a look. I'm supposed to talk about a couple of these things, so I'll do that. All right, this is the first place we went to visit. This was near the Namatis. Dr. Namati, who will be here a week from tomorrow night. So plan on coming back here Friday evening, September 15th, 7 p.m. for a presentation by Dr. Namati. He'll be talking about the search for exoplanets. That one will be a little bit more technical than the talk that we're giving today. This is not a real technical talk that we're doing. We're just going to talk about our eclipse trip. But he arranged for us to go in and see the U.S. Space and Rocket Center, which is very close by there. And you can see that this is a really, really neat museum, if you will, because it houses a lot of the rockets that were built by NASA through the years. And I'm standing right next to a Saturn V rocket. This is what took us to the moon. This 360-some foot tall rocket, like a giant office building, was built and designed to take men to the moon and back. And so this is one of the actual rockets that was built but never launched, of course. And of course, we discontinued the space shuttles a few years ago. NASA no longer launches our own vehicles into space. This was the last launch vehicle that NASA used. And this is one of the remaining space shuttles. They actually took this with the booster, the fuel tank and the booster rockets and all. And they put it up here at the Space Center for people to see. This rocket center has a long history of the things that NASA has done through the years and our drive to explore space. And so it's a very interesting place, and I encourage you, if you have a chance, if you're going anywhere near Huntsville, to go ahead and visit the U.S. Space and Rocket Center. And so we went there on the Saturday. I think we left Friday, August 18th, before classes started. And I drug Ari away from all of her international duties to come along. And then we drove to Huntsville. We stayed with the Namatis, and we went to the Rocket Center on August 19th, that Saturday, before the eclipse. And I figured we should do something space-related in case it turns out to be a cloudy day on Monday. We don't get to see a solar eclipse. It's a long drive to make just to see a cloudy day. So I thought, well, let's do something space-related in case it just turns out to be a cloudy day anyway, right? So we had a good time and saw lots of space-related stuff there at the museum that Saturday. And so that was a lot of fun, and it was a beautiful day. Nick, who's not here, I'm kind of glad Nick is not here. He's a member of our trip that is not here with us today. He's out flying airplanes somewhere. I think if he were here, he would talk about my driving. So, he's not here. Anyway, we drove through some rainstorms at some point where I couldn't see a thing, but hey, we're still here, so I can't complain too much about my driving. But anyway, Nick and I, he's the brave one because he and I got on one of these little rides where they launch us up 140 feet high and then you're in free fall. Whew! You feel that one. But anyway, that was a lot of fun. So there's lots of fun things to do at the U.S. Space and Rocket Center if you get to go. All right. What else am I supposed to talk about here? Oh, yeah, a little bit more on the U.S. Space and Rocket Center. Here's Stephen, the tall guy who's going to be talking after me, did not meet us in Huntsville because he was coming directly from Chicago and he would meet us in Hopkinsville, Kentucky. Instead, just the five of us, Nick, Luke, and I, Ari, and Haley. And this is Rachel Namati, the youngest of the, how many? There's 5 Namati kids. We've had 3 of them graduate from Laterno now. We didn't get the 4th Namati kid. He went somewhere else, but I'm still working on trying to get the fifth Namadi kid to come to Laterno. So she's a senior this year in high school. She went with us to visit the U.S. Space and Rocket Center. And anyway, we had lots of fun together that day. I would mention that the Namadis didn't end up coming up with us to see the eclipse because David, the oldest one, had some problems health-wise, and so that was a bit unfortunate. Okay, some more pictures from the U.S. You loaded all kinds of pictures that I didn't know about. The three girls, they jumped inside the Apollo space capsule to see what it's like. This is what they were in when they came back to Earth. That was the only thing that made it, of that huge 360-some foot rocket, the only thing that makes it back to Earth from that entire trip is that little capsule with those three astronauts in it. And there are the girls sitting in it. And anyway, this is the inside area of the Rocket Center, I guess. And our hosts, while we were in Huntsville, the Namadis, they went ahead and stayed, I guess. Well, I think they did try to drive a little north to see a little bit of the path of totality. Luke was going to be talking about all the details of the eclipse in just a moment, but they did drive north to try to view the partial solar eclipse, but they only got to see a few seconds of it. They were just barely within the path of the totality. There's Dr. Namadi, there's his wife Beth, and there's Rachel, and I think David in the background, and John, and Michael. But anyway, they were our hosts when we were in Huntsville, and our host when we got to Hopkinsville was Georgia Emery. And so very, very special, unique lady. A Turno graduate sometime in the 80s. And she, yeah, they're telling me I'm done. So anyway, Stephen's up next. He'll tell you more.
Hey guys, my name's Steven. I'm a senior here. Chose astronomy because it sounded like a really cool class. And then Dr. Ball this summer sent out an email inviting us to go on this trip. And so that's how I ended up on it and didn't meet them down here beforehand. So this is Georgia Emery. She was our wonderful host. She let us stay in her house for 3 days and welcomed us into all of her life. Lots of stories, lots of late nights, especially for Luke. So I never actually saw Luke go to bed. I went to bed pretty late, and every night he was just in there after me. But she was a wonderful lady. She has a lot of different passions and interests. She is a landlord. She's a lawyer. She runs different shops. She does everything you can think of. She loves the Lord dearly and really showed us her passion through her hospitality to us. So like Dr. Ball said, we got there Saturday night and attended church the following morning. And then following that, there was a massive potluck that we were invited to, I think because we showed up. Not sure about that yet. But she organized so many little events to make our trip special. And that really made the trip for us. So after the potluck, we went to Pastor Blazer's house for the star party that evening. This is a picture of the Foursquare Church. So classic little church. It's been built on since then, but it looked almost the same. We enjoyed it there. Dr. Ball had a wonderful sermon, and then we moved on to our star party that evening. So this is a map of what the sky looked like that night. We have all the different constellations up there. If you guys look, you've got Jupiter up in the top corner. That was the first one we actually looked at because it was disappearing off the horizon pretty soon after sunset. And then we followed it up with Saturn, and then the teapot is right here. You can kind of see that one. And then the last one we looked at was the Andromeda Galaxy. So Jupiter, this picture we have up there is the one we actually were able to take. It was a lot clearer through the telescope. Our phones, however, didn't take great pictures. But Jupiter is our fifth planet from the sun. And as we learned, if you combine all the other planets in the solar system, it's 2.5 times the size of all of them put together. And so it is by far the brightest thing up in the sky that we were able to see that night, and it was a lot of fun. And you can only fit around 300 Earths into it, so to give you perspective. So that was really cool, and we actually got to see 3 out of the 4 moons. This picture doesn't give a good glimpse of it, but we were able to see 3 out of its 4 major moons that night. Moving on to Saturn, once again, blurry images, but this is what it looks like in real life. And so Saturn is our 6th planet. It can also be seen with the naked eye. And like Jupiter, it's a gas giant, and it's only about a third the size because it takes 95 or so Earths to fill it. Following up with that, we looked at the teapot, which I described. This part of the larger constellation, the Sagittarius. It's the giant hunter with the bow. So the edge of the teapot right there is the arm of the bow, and the arrow sticking out from it. So we were able to see that one. That was really cool. And around it were a bunch of other clusters of stars that we got to look at and focus in on. So this is the full Sagittarius constellation. And his legs are going down, his arms coming back. You can look it up if you want. There's a lot better pictures out there. So last one we looked at, Luke focused this one in on us. It's the Andromeda Galaxy. It is around 2.5 million light years away. We were able to see it, and Dr. Ball actually helped Luke find it. He had a laser pointer, was pointing it up at the sky, where Luke's trying to focus the telescope in on it. And so this one didn't appear for a while, but it's a very impressive galaxy, and as we zoom in on it, it has 2 massive spiraling arms and is our next major galaxy that's close to us. So looking at it through the telescope didn't look anything like this, unfortunately. Looked more like kind of a blurry dot, but we were able to see it up close and get a better image of what it looked like. Next, handing it off to Luke. He's going to talk a little bit about the telescope and how we viewed everything.
Yeah, what would a star party be without a telescope, right? My name is Luke Grosh, and I'm a senior in engineering physics. Fun stuff. You should all take physics. Laser pointer. Here we go. Yes, good man. So, this is an 8-inch Newtonian reflector telescope. Pretty simple how it works. You get light coming in here, collecting from this mirror, 8 inches across, bouncing up to this mirror, and then up into an eyepiece, which is right here. And different eyepieces give you different levels of magnification. This is a very big eyepiece, and you get less magnification out of that. And the smaller ones give you stronger. But there you have it. That's how that works. This telescope is a bit unique. It's a bit special. It's been through the school of hard knocks. If you come up afterwards and look, you'll find dents and scratches and broken pieces here and there. But it still works, right? And that's what's important. That's what we need. So if you ever need a recommendation for a good telescope, buy that one. Except new. One of the other nice things about it is the setup is very simple. I'll walk you through the basics of it. First, you take this tripod, and you can't see very well, but right here there's a little sticker that says north. And you point this straight north. I'll tell you why in a minute. But next, you set this thing up here. This is an equatorial mount, and I'll also tell you about that. And then this goes on here to brace the 3 legs so that it doesn't shift around in the middle. And then you put a counterweight to balance it. And then on comes the telescope itself. And last but not least, you put this finder scope on. Now normally, this finder scope is really useful because you can look through it and you have a very large field of view, and so you can kind of see half the sky at a time and dial in on exactly where you want to point your telescope, because in the telescope you can't see a whole lot of the sky, and so if you're looking through here, you could be searching around for hours and not be able to find what you're looking for. Unfortunately, this is very broken. See this handy-dandy little screw right here? That one works great. But the other handy-dandy little screw that's supposed to be right there isn't. And so when you stick it on here, you can't align it with the telescope, and it is more or less useless. So, to fix that, we just had somebody use a laser pointer. I could track it in, which was great for me, because I could just kind of stand there and follow a laser down, but it was kind of a pain for the guy that was holding this laser pointer in one spot exactly for about 5 minutes, which just happened to be Dr. Ball, who had a tired arm by the end of it. And let's see, where did I go with next? One of the other things that you might be wondering about is this little piece of equipment. Generally, you don't need this. This is only if you're going to look at the sun. This is a solar filter. If you try to look at the sun without this, you would potentially damage the telescope and you would go blind, which nobody wants. But the next question is, why is there tape and cardboard on it?
Because half of it broke.
Bingo. It's not a standard feature, surprisingly. So last year it got dropped, and now it looks like this on the inside, which doesn't work so great because it lets a whole lot of light through all those little cracks. So before we left, Dr. Ball and I took a day, and we said, all right, let's set up this telescope outside and find out if we're going to run into any problems, fix some of those problems. And he showed me this, and I thought, you know what? I bet I know what we can do with that. So I slapped cardboard and tape on it. And now we have half of the solar filter. And there's a few other things we found out that day. Namely, that Texas is really, really hot. So it was about 2 or 3 o'clock by the time we went out and set up this telescope. And in Texas at 2 o'clock, you just get drenched in sweat. But it was worth it because we got to set it up, we got to see sunspots, and a few other cool things. One of the other things we tested out was actually later on the trip, was this little thing here, which is a camera specifically made for the telescope. There it is. So this goes in here. And so I was thinking, well, this will be perfect. We can just videotape the solar eclipse. We'll have a perfect camera. It'll be wonderful. And then I set this thing up, plugged it in, got it all working, and you can only see through this camera about 1/4 of the sun at a time, which was very disappointing. But we got around that by using our phone's camera, which worked-ish. More or less. Sometimes less than more. But this equatorial mount is kind of the pride and joy of the telescope, because what that does is it counters the spin of the Earth. So without that, you would have to realign your telescope every couple of minutes if you wanted it to still be pointing at the same thing in the sky. And this is why you have to point that little bit toward the north. This is a circumpolar of the North Star. So right there is the North Star. And as the Earth spins, the North Star is right pretty much smack dab where the spin axis of the Earth is. So the Earth is spinning like this, and right in the middle, it's pointing straight to the North Star. And so if you focus in on the North Star, all the other stars will go around it. So what you can do is you point it straight at the North Star, align everything, and then once you focus in on Polaris, not Polaris, anything else, any other star except that one, and engage the tracking, it'll rotate against the Earth and keep it in the field of view for you, which is really handy, and it saves a lot of time.
Doesn't that mean you have to bend down a lot?
Yes, sometimes. We'll get to a story about that a little later, actually. So, one of the other things, because of that, because we didn't use this, our pictures, I must admit, did not come primarily from our phone camera. They came from our neighbor, or well, the pastor's neighbor, who very kindly gave them to us out of the generosity that he had, because he set up a very nice camera that was, about this big, stuck a solar filter on it. The only thing he was missing was an equatorial mount, so he did have to readjust every 2 minutes or so. But his pictures are beautiful. Anyway, on to more solar eclipsey things. We've referenced totality. Now, totality is a fairly simple thing. It's just when the moon completely covers the sun. And this is the path of totality across the United States. This is the only solar eclipse in a very, very, very long time that's crossed the entire continent of the US. And the path of totality is about 70 miles wide, and we were right there in Kentucky, right there. This little dot is where NASA set up. They determined that that right there exactly was the ideal spot to view the eclipse from. And so they had all of their people out there with the big science-y equipment, and we, conveniently, were right around here, Crofton Road. So we really kind of got prime viewing for that solar eclipse, and it was very much worth it. If you guys get the chance in, 6 years, however many of you are still in Texas, there's another one passing through. Very worthwhile. Go see the path of totality. There's nothing like it. Couple interesting facts about totality. It took an hour and a half for the moon's shadow to cross from Oregon to South Carolina. And if you do the math on that, it travels at about 1,400 miles an hour, the moon's shadow. Real fast. Not going to outrun it. And you could try, but I wouldn't bother. I also don't like running. Now, solar eclipse. So, that's the sun through a solar filter. These are sunspots. These little spots there, they're points on the sun that are cooler than the rest, and so they don't give out nearly as much light. So with a filter, you can see them. There's a few interesting things that happened on that solar eclipse when it started. Firstly, though, we were all pretty tired. We've been traveling for a while, and Dr. Ball, he's dragging a little bit, and thought, oh, this might fall asleep in the middle of this. But as soon as we hit that little sliver right there, I said, hey, it started. And he perked right up. He got all excited real quick. And then for the next hour and a half or so, we watched it go and go and go some more. But some interesting things happened during that. And one of them is that it gets dark very slowly, but it does get dark, which makes sense because you're covering up the sun. But with that, it got cooler, dropped by about 10 degrees, which was very nice because it was a hot day. And we were sweating again while setting up that telescope. So it gets cooler, gets dark, kind of a lot like dusk, really. And it fooled the animals into thinking it was dusk too. So about 30 minutes in, someone says, "Do you hear that?" I said, "Hear what?" He said, "The rooster." I said, "Oh yes, I did hear the rooster." I said, he thinks it's nighttime. It did look like it. One of the other things that popped out was some stars. At, I believe it was around 3/4 covered, one of the guys said, "Hey, what's that?" It was Venus. You could see Venus. Just a little ways away from the sun, which is unusual, but very interesting. There will be a picture later of all that you could see up there. So, a couple interesting facts about why this all works. How can the sun be completely covered by the moon, but we can still see the corona? Well, the moon is approximately 1/400th the size of the sun. And it just so happens that almost exactly the distance between the moon and the earth is also 1/400th the distance between the sun and the moon. And if that wasn't the case, either the moon would completely cover up anything interesting during a solar eclipse, or it wouldn't cover up the photosphere, which means you wouldn't be able to look at it at all and see totality, which is very, very impressive. And I've referenced the photosphere, but there's also the chromosphere, which this redness right here is the chromosphere, which is very pretty. Anyway, the pictures still don't quite do it justice. Seeing it in person, seeing all these little swirls and tendrils in the corona, there's nothing like seeing that in person. It's completely unique. I very much enjoyed it. And I also have to mention that I grew up in Papua New Guinea, and I did a lot of work with villagers out there that technology and astronomy is very abstract to them. And I have an insight into that mindset from that period of science in our history. And if I was in the path of a total solar eclipse, having no knowledge of astronomy, I would for sure think that the Earth was ending. It's so dramatic, this change. I mean, you see the moon come in, and it just completely blots out the sun, except this radiating span of tendrils that just come out of it. It's incredible. But just before totality came, that equatorial mount kind of stopped working. I came in and I took a look and I said, I can only see about half the sun. And so I thought, well, that's strange. This should be tracking quite well. And come to find out, a couple of these knobs, let's see, this one, or no, one on this side and this right here, or that right there, had jammed up against each other and frozen it. This was 3 minutes before totality, the whole reason that we've gone up there. And so I kind of came over here and wondered, can I just work this manually? Can I adjust it just by itself? And no, it was jammed, and it was jammed good. And so I thought, all right, we got 2 minutes, 45 seconds. Let's flip this sucker around. And so unlocked everything, and it's this way. It spins in this axis. That's where it got jammed, right there. Right there. Can't move. It's exactly where it got jammed. And so Thought, all right, we'll just move it over here. Speaking Jim. And point it like this. And that's exactly what we did. And now that we've got it pointed this way, we've got about 2 minutes, give or take, before totality. And Dr. Ball is next to me saying, you got 2 minutes. You got 1 minute 45 seconds. You got 1 minute 30 seconds. And I'm sitting here, where's the sun? I can't find the sun. And so Stephen comes and, you know, we use the shadow, what's left of the shadow, to kind of get a ballpark. And I figured out earlier, thankfully, that to find the sun, the easiest way to do it is actually just to take out the eyepiece. And even though it's not focused, you can still look through and you can still figure out where the sun is by how much light's coming in. So I take the eyepiece out and I'm searching around for it. He says, you got 1 minute. Oh boy. So 1 minute left and I see the sun in there and I'm like, okay, let's get the eyepiece in. So I stick the eyepiece back in and I don't see the sun, so I move it around a little bit more and still don't see the sun, so I take it back out. I'm looking around and he said, you got 30 seconds. Like, oh dear. And so I finally find the sun again with about 25 seconds, stick the eyepiece in, got it. Realign everything, engage the tracking again with 15 seconds to spare.
Were you successful?
I was. We got some good pictures through our phones, and it was well worth it. Seeing totality, something that looks like that, except more magnificent, if you can imagine, was very, very worthwhile. Including the driving, you know, the trips up there. Georgia trying to set me up with her daughter. I wasn't the only one. She tried to set all of us up with her daughter. Very insistently. But I was all right. Polite about it. The interesting part about that was her daughter was not there. But the other thing that we use to view the solar eclipse, we use binoculars, which have little solar filters on them. They're very wonderful. Hey, those lights are bright enough. Who would have thought? Anyway, the binoculars were pretty good. I didn't end up looking at the solar eclipse through the binoculars because I was mostly using a telescope, which I think is better, but can't be too sure on that count. But yeah, there you have it, the solar eclipse.
So my name is Haley and I'm a junior at LeTourneau. And to be honest, after this trip he was like, okay, you're going to have to speak for the class. I can do that. Okay, I was still nervous about that. And then he comes and he's like, okay, you're actually speaking for a seminar. It makes me a little nervous. So he's like, you have 6 options. You can speak about any of these things. These guys are so incredibly brilliant. I could not tell you about any of these things or the telescope. So I was like, I'm going to do a 30-second devotional. So that's what I chose. They already covered Andromeda, and it's 2.5 million light years away. And as I looked at it, I was like, who am I? Like, in this universe full of billions of galaxies, who am I? Like, I'm a speck of dust compared to these places. And so at the end of the night, I texted my dad, let him know that the alumni were fine, let him know that I was safe, and told him all these facts that I was learning. And he replied with a verse, and it says, lift your eyes on high and see who has created these stars, the one who leads forth their host by number. He calls them all out by name because of his greatness and his might and the strength of his power, and not one of them are missing. And in that, in his response, I didn't have to question anymore who was I, because I was made by the same creator that created the galaxies. And so it's short and sweet, and that's what I have. And I think we're going to open it up to questions now.
This is Ari. Ari's from Mongolia. She went with us on the trip. And Nick is Nick is not here with us, but he's the other one. But if you've got questions, any one of us will try to answer. Okay.
I noticed in the diagram of the telescope that I believe it was Luke
Yes.
showed earlier, the light came around the tiny mirror. How does the little tiny mirror not block some of the light?
It does.
It does.
Just not a lot.
You don't need it all. All you need is just some coming through.
So about how much can you see? Like, is there a little dark spot right in the
We
center?
can live without all of this. All you need is a light coming through here, and then you focus on infinity. So you don't see the apertures or the things that are blocking it. You don't see it. You just see whatever you're looking at a distance. So as long as some light's coming in, you'll see it.
It's focused so far away that it doesn't matter, effectively.
Anyone else?
Yeah.
What would happen if you were to like center the telescope on the sun and take the sun cover off and look at it with the glasses?
Glasses? What?
Would they be sufficient to protect you?
You can try it and tell us.
Some people do project the light coming through their telescopes onto a screen and look at it that way. But that's hard on the optics of the telescope. It gets hot. And it really heats up with that much sunlight coming in, so I don't allow that personally. I want to keep this in working condition for a while.
Yeah, you had a question?
Yes, I have a question for any of you. My sister said she didn't see the diamond. And what did she mean by that?
Yeah. It's coming. Okay, so diamond should be, this is right after the solar eclipse. So that's, there we go. That's the diamond. It's when the sun peaks right over the edge of it. It gives a really brilliant star shape that pops right to the top. So,
Thank you, Stephen.
It's just very brief. Other questions? I saw some other hands up.
What's the farthest you could look? Like, what's the farthest distance you could zoom with the telescope?
Well, I insisted that we, during the star party, see the Andromeda Galaxy because I wanted them to see something that was over 2 million light years away. There's essentially no limit how far you can see if you can pick up the light coming through. And so modern telescopes today are looking to the very limits of the visible universe, 13.6 billion light years away. So you're not limited to how far you can see if the light is actually reaching us.
How clear are those images, though?
Well, you'll need a much bigger telescope than this one if you want to see some clearer images from those distant sources. But you can see actually even some of the Andromeda Galaxy.
Are you familiar with the Hubble Deep Field project? And those were very, very far away. And we picked them up.
Okay, well, question?
Question for those who went on the trip, not necessarily you.
he went on the trip.
How much did you have to pay to go on this trip? Like, what were the consequences of going on this trip as opposed to not? So you,
Nothing.
Falls just literally said, hey, you guys want to come?
Pretty much.
Pretty much.
So why did no one else join you?
That's a question I asked myself several times as
Why
well.
was there only 5 of you?
Because we're the awesome ones. That's why.
I think it's a good note to close on. If you want to learn more about this, if you have an interest. Whoa! Back off. Okay. So if you want to learn more, if you're wondering why more people didn't come out to learn about this, give us a chance to join us for lunch. We'll be in the Joyce Room of the Corner Cafe, and you can ask these guys more questions about their adventures at that point. And I also want to remind you of the 2 seminars next week. Okay, both Thursday at this time, and then Friday night. Okay, we'll see you all next week.
Awesome.
Sir, were we supposed to sign in to prove that we were here?